All right, stop whatever you're doing because I'm about to blow your mind. Imagine this. Time isn't real. Or at least, not in the way we usually think about it. What if I told you that the ticking seconds on your watch, the irreversible flow of moments, might actually be an emergent property of something deeper than physics itself? Stay with me. By the end of this, your entire concept of reality might change. Hey there. It's so good to have you here with me, diving deep into what makes the universe tick, literally. This is Hyperfocus, your go-to for the kind of advanced science that keeps even physicists up at night. If you're new here, welcome. Grab a coffee, a notebook if you're feeling ambitious, and let's get into it. And to everyone returning, thank you. Seriously, the fact that you're back means you love unraveling these mysteries as much as I do. And building this little community just fills me with joy. Okay, ready? So first, let's unpack what physicists call the problem of time. You'd think time, as fundamental as it feels, just happens. It ticks, flows forward, and that's that. But in quantum mechanics, time is treated as a background setting, a parameter outside the dance of particles and probabilities. In stark contrast, Einstein's general relativity makes time incredibly dynamic, an integral part of spacetime that bends and warps depending on the presence of energy and mass. These two visions of time don't agree, and it sets the stage for one of physics' most head-scratching puzzles. How can quantum mechanics and general relativity both be right, but tell us contradictory things about how time works? Let me make this concrete. Say you're standing near a black hole. The extreme examples are great teaching tools. To someone light years away, maybe with their telescope pointed at you, time seems relatively normal. To you, near the black hole, time would slow down drastically. Relative to the observer farther away, you might age way more slowly. And then, quantum mechanics steps in and asks us an entirely different question that, ready for this, has less to do with when time happens and forces us to consider what is time. Here's where it gets wild. The Page-Wootters mechanism. Ever heard of it? This is a lesser-known but beautiful approach to explaining why we experience sequential moments rather than, well, nonsense. Page and Wootters proposed that time, as we perceive it, might not be fundamental. According to their idea, systems could exist in what's called a quantum superposition. Yes, that same principle that keeps Schrödinger's infamous cat alive and dead at the same time. In this superposed state, time is relational. It emerges when you look at one system relative to another. When you connect their state, a shared time springs into existence, like a wave collapsing when observed. This doesn't happen out there, in some clock-like ether. It's right in the comparison. You look at one system, you experience time. Hold up a second. Are you feeling what I'm feeling? This changes everything. If time is relational, not fundamental, then what does that mean for free will, determinism, or even causality? But let's not stop there. How does quantum gravity, the theoretical unicorn marrying general relativity with quantum mechanics, approach the problem of time? Most approaches to quantum gravity, like loop quantum gravity, suggest space-time itself might not even exist fundamentally. Instead, it's emergent, an illusion formed by deeper physical underpinnings. Imagine space-time like a smooth picture on your laptop screen. Super zoom in, and you'd find individual pixels. What's below those pixels, though? Quantum events, entanglements, relations that conspire to make it look like space-time. To borrow from science fiction, space-time could be something of a hologram. I know, it just keeps getting crazier. Some research even suggests time might be a byproduct of quantum entanglement. Entanglement, that surreal connection between particles separated by light years, could actually be weaving the fabric of space-time itself. Ever hear of the ER-EPR conjecture? It's this deeply poetic proposal that says wormholes, the Einstein-Rosen bridges of science fiction, are equivalent to entanglement between quantum systems. Spooky action at a distance isn't just spooky in this framework. It's the actual stitching thread of reality. Time? That's just the seam that makes the stitching work for us to process. Alright, this is where I slow us down for a sec. Normally, we feel like time flows from past to future, right? It's practically baked into human consciousness. But a surprising branch of physics has questioned, does time even have a direction? You see, the equations in physics, most notably quantum field theory, don't inherently favor forward action. The arrow of time, defined by increasing entropy, only emerges in large, macroscopic systems. That means, on the super tiny quantum scale, there's no particular reason time prefers its usual direction. Freaky, right? Here's an analogy. Imagine your favorite song on a record. You can move the needle forward or backward along the grooves, just like time might work in equations. But listening to that music unfold depends on it being played in one direction, start to finish. Could time, as we think of it, just be the groove our brains need to process reality? If your head isn't spinning yet, there's more. Experiments delving deeper into quantum theories of time show something stunning. Emergence doesn't only explain why time feels consistent for us, it sidesteps concepts like beginning or end. Certain views put forth by loop quantum cosmology suggest the Big Bang, that iconic start, isn't a singularity. Quantum corrections make it possible the universe existed in novel forms long before what we consider the beginning of time. Imagine a cosmic loop, self-sustaining and infinite in experience. We're left to ask, how much of time's nature is something we invent to explain it rather than something objectively out there? This is the part where I need your input. What do you think time really is? An illusion neatly pieced together by entangled particles? A metaphor for human perception? Let me know in the comments. And hit that subscribe button. We're just scratching the surface of what Hyperfocus has in store. Every click helps our microscopic yet growing community thrive. Besides, it's your engagement that drives geeky explorations like this one. To wrap things up, here's where you and I leave today. If time is truly emergent, then you, yes you, are like an artist, painting with it. Every choice, every connection you recognize or don't, reshapes your experience of this grand symmetry-breaking illusion we call reality. Stay hyper-focused, and remember the universe breathes in rhythms too beautiful to confine in seconds and minutes. Now, go out there and savor how bizarrely perfect time feels, knowing it might be all in your mind.